I'm Doug from FirstTech. In today's segment of myFirstech Academy, we're going to talk about relays. There's a lot of things to know about a relay. It's a very useful tool. What we have here is a relay that I've taken the top off of it, so hopefully it's easier for you to see what's actually happening inside a relay. A relay is basically just an electromagnetic switch. So basically what that means is there's 5 pins on a relay. We'll go through the description of each pin and what it does one at a time. So if you look at the relay, first of all, you'll notice a big coil of wire. Okay? So that coil is what actually creates the magnetic field that will allow the switch to be moved from one position to another. So pins 85 and 86 on a relay are either side of that coil. When you pass current through the coil, it creates a magnetic field and moves the armature in the relay, which is this little flappy part right here, from one side to the other. It actually is spring-loaded on that armature, so the normally closed circuit obviously is just that, normally closed, and when the coil is activated, it creates a magnetic field that draws that armature across and touches the normally open side of the circuit to the common pin. So, with all that being said, so 85 and 86 are either side of the coil, and then you have pins 87, 87A, and 30. Those are the 3 pins that are functional on the relay that are basically oriented in the center. So if you look at the relay in this orientation with the bottom pin parallel to the coil pins, it will go 87, 87A, and 30. And as you can see on our diagram right here, your normally closed would be 87A with 30. So 30 is the common pin on the relay. So the pin at the bottom that's parallel to the 2 coil pins, you always remember that? That's your common pin. So that common is always going to be in contact with either 87 or 87A. At rest, with no current applied, right now you will find that pin 30 has contact with pin 87A. And that's your normally closed circuit. So we'll demonstrate that with our multimeter, which is set for continuity right there. So if we touch, I've got my probes on pin 30 and 87A. That demonstrates continuity there, showing you that you do in fact have a closed circuit between those 2 pins. Now what I'd like to demonstrate is what actually happens when you pass a current across the coil. I've got a power supply in this bench that will allow us to test this to show you what actually happens. So the thing that a lot of folks don't understand is that the coil is non-directional as well. So you can pass a current through the coil in either direction and it will create that magnetic field to move the armature in either direction. So what I'm going to do now is I'm going to pass a current through that. You hear it click. So if I take that off, and when you actually pass that current, you'll see the armature moves. That's what the click noise is. When that current gets passed through there, the relay clicks because that armature is immediately moving from one side of that contact to the other. So now, with the current going through the relay, I'm going to connect my multimeter probes to pin 87 and pin 30. And now I have continuity between 87 and 30. So that's with current passing through the probe. As soon as I remove that 12 volts, that moves the armature back to the normally closed position. So very simply, like I said, an electromagnetic switch. When I pass a current, it flips the switch. So that's the mysterious relay. Really not that complicated. These can be used in a multitude of applications. However, that's all there is to it. Just an electromagnetic switch. Hopefully this helps. If you have any questions about this video or any of our videos on the myFirstech Academy page, please feel free to reach out to us and ask.